Alright, welcome back. This lesson we're going to be looking at common factoring, our third lesson of this unit, and ultimately our goal is to get towards interpreting and solving questions related to quadratic relations. And I know I've met my learning goals if I can use this problem solving to create and solve equations that involve binomial expressions. And at this stage, here's evidence of your learning. If you can do these questions here, then it indicates you're on the right track and that you have been able to learn what's needed. And these other two questions, the second and fourth, still require more skills to solve. Continuing on, I'd encourage you at this point to pause the video and try and do these questions. This is a quick review of grade 9 and takes a look at some of the skills that you'll need for this lesson, and also helps with a bit of understanding. Just to take them up now, 2xy times x squared turns into 2x cubed y. This 2xy multiplies the 2x, that turns into plus 2 times 2 is 4. X times x is x squared. And we got a y that comes along with it. 2xy times plus 3 turns into plus 6xy. There's no need to simplify at this point because none of these terms are like terms. We're going to now take a look at expanding and simplifying this expression. This is equal to 9 times 3 is 27. X times x is x squared. Y times y is y squared. 9 times minus 2 is minus 18. X times x squared turns into x to the 3. Now there's 3 x's. Y times y is y squared. Now we're going to multiply these terms here. 9 times minus 4 is minus 36. X times, well, there's no x's there, just x. And y times y will be y squared. Moving on. So let's take a look at our common factoring today. Our goals of this is to factor polynomial expressions involving common factors. I know I've met my learning goals if I can factor expressions like these below. And for the most part, you can see that there will be common factors that are monomials, but down here, there's actually an x plus 2 and x plus 2. You can also factor out things which are not just monomials, not just one term, but binomials, trinomials, and more. And just to take a look at some key terms that we'll be using throughout this lesson, a factor is a term considered to be a term. A is considered to be a factor of b if b can be divided by a. So 2 is a factor of 6 because 6 can be divided by 2. 3 is also a factor of 6 because 6 can be divided by 3. The greatest common factor is the greatest factor between two or more terms. So if we look at the GCF, this is a short form, the greatest common factor of 8x squared and 12x is going to be 4x. 4x can divide 8, so 8 divided by 4 is 2. 4x could also divide the 12, that turns into 3, and between these there's 2 x's here and there's 1 x here, so we can divide out the x. Factoring is finding what to multiply to get an expression. So we're going to take a look at the steps to do that here. The first step will be to determine the greatest common factor of each term. We're going to divide each term in the expression by the GCF, write the GCF times the divided expression in brackets. And this is a really important image for students to really get what's going on. The difference is this here going this way is expanding, where we multiply through, and essentially factoring is going backwards or dividing out a factor from multiple terms. So here's our first example, and I'm going to show you something interesting, and what I'll do is instead of writing these exponents, I'm going to write it out a little bit bigger. This is a good visual for students to understand what's going on. And we got the plus 6xy. What's common between these two? Well, the number we have to look at, and the number, the greatest common factor between 2 and 6 is going to be just 2, because 2 can divide both 2 and 6. But when we start looking at the letters, we can take out 1x here, we can take out 1x here, so we'll write the x. We can't take out any more x's because there's no more x's to take out over here. That one's already taken. We can take out a y. You can write the y down here. And we can't take out anything more. There's one z here, but there's no z here. So the greatest common factor of these two terms is 2xy. I'm going to write a brackets, and I'm going to write what remains. So the xz is here. Got a plus, and what remains over here? Well, technically there's nothing left, but the 6 did divide it by 2, so it turns into 3. And so what you see here is the greatest common factor multiplied the resulting terms, and what was left over is what was divided out. So let's go ahead and take a look at some examples. These are a little bit more complicated, but the same process applies. We look at the numbers, 27, 18, and 36. The greatest common factor of those numbers would be 9. We look at the x's. I've got 2 x's, 3 x's, 1 x. I can only take out 1 x because that's common among all of them. I look at the y's. There's 2 y's, 2 y's, 3 y's. I can take out 2 of them. I cannot take out more than the lowest exponent. And there's no z's. I've taken out as much as I can take out. 27 divided by 9 is 3. X, I had 2, I took away 1. There's 1x left. I had 2 y's, I took away 2 y's. There's no y's left. I move on to the next term. Minus 18 divided by 9 is 2. I had 3 x's, I took away 1. There's x squared left. I had 2 y's, I took away 2 y's. There's none of those left. Moving on to the next term. Minus 36 divided by 9 is going to be 4. X take away an x. There's no more x's left. I had 3 y's. I took away 2 y's. There's 1 left. And I don't bother writing the exponent because y to the 1 is just y. So there's my greatest common factor, and I've divided every single term by that greatest common factor. Notice on this next one below, we've got these binomials. They are the exact same. We can actually factor those out, and that's an interesting thing that we can do. We write the factor outside, x plus 2 here. And what remained is this 3x plus 2. So in another set of brackets, we're going to put 3x plus 2. So in the next set of slides, I'm going to encourage you at this point to pause and try and do these yourselves. Okay. Now that you've had a moment to pause and take a look at how to do these, we're going to take it up. We've got the 4, the 10, and the 12. The greatest common factor between all of those would be 2. We've got 2 n's, 4 n's, 3 n's. The lowest exponent is the 2. I've got 2 n's that I can take out. I've got p3, p2, and p2. I can take out p squared. And that's as much as I can take out, so this is the greatest common factor. Open the brackets. 2 divided by 2 is 2. I've got n squared. I had 2n. I took away 2 n's away. I had 3 p's. I took away 2 of them, so I got 1 p left. I'm done with that term. Plus 10 divided by 2 is going to be 5. N squared. I've got no p's left. Minus 12 divided by 2 is 6. I had 3 n's. I took away 2. There's 1 n left. And I had 2 p's, and I took away 2 p's. There's none left. And it's also important to understand that if I really wanted to check my answer, I could also expand out, and I should get the same thing. Expand here, here, and here. And notice that I've got an equal sign, which says that this expression up above is the same as this thing here. Going to take out this x plus 3. It's common between the two. Got 2x minus 5. And we've got the x plus 3. It doesn't matter which order you write it in, actually. 2 times 3 and 3 times 2 are both equal to 6, just like this would be equal to x minus 3 times x minus 2x minus 5. You can do it both ways. We're going to look at our last set of examples here. We've got something called factoring by grouping. So what's going to happen here is, let's get rid of that. We're going to take a look at these as a group. So we're going to group those two terms off with these two terms. And there's going to be a reason for this, and this is an intermediate step. So if I were to write this 2x squared minus 2x. And we've got the plus. We're going to group these 5x minus 5. And what we can do is we consider factoring out this 2x out of this expression here. 2x. This will turn into 2x divided by 2x is just x. And we've got this minus 1. And we can factor out a 5 from this other expression. Plus 5. 5x divided by 5 is just x. And we take out the 5 divided by 5 is minus 1. And what we start to notice here is that we've got an x minus 1 and an x minus 1. So we can actually go one step further and factor out the x minus 1. So this will turn into, take out the x minus 1 out front, and we're left with the 2x plus 5 and another set of brackets. And just to show you another one, instead of actually writing out the brackets, I'm just going to factor in this next step. 9x squared plus 15x, I can take out a 3x from both of them, and that will turn into 3x plus 5 here. And this other side, I've got the 6x plus 10. I can divide those both by 2. So I'm going to, that'll turn into 3x plus 5. And ultimately you're like, oh, okay, well this is working out very nicely, and it's supposed to. And when we learn, and what we'll learn in future lessons, is that there's a reason why we're doing this. Right now it just seems trivial. Okay, well, how did that work out? Well, we'll learn about that in the next lesson. At this point, I encourage you to pause and try and do these yourselves. And it's also important to note that right now these are lining up nicely, that it will work out to a group factor, but sometimes you may have to rearrange these middle terms. And our next step in our next lessons will be to figure out how do we get these two numbers so that we could actually break something called a trinomial up into multiplication of binomials. Again, pause right now, take a few minutes to try and do these. Okay, now that you've had a moment to try and do these questions, we're going to take them up. We're going to group these two terms and these two terms. This will be equal to, well, the 3 and the x can come out of the 3x squared and the 12. So 3x squared divided by 3x is just going to be x. Minus 12 will turn into 12 divided by 3 is minus 4. And the x came out already. Plus, we can divide these ones by both by 2. And 2x turns into x. 4 will turn into 2. Oh no, we can't group back to this one, because if we notice here, this and this are not the same, so we cannot go any further than that. However, let's hope that we can still do it with this one. Is equal to, we're going to group these two together and these two together. We can take out the 2x, and we've got x minus 4. Grouping these ones out, we can take out a 3 plus 3 times, this will turn into x minus 4. So we can factor out this binomial because it's the same for both of them. And this will be equal to x minus 4 in brackets. The brackets are important. Times brackets, what remains, this 2x plus the 3. And that concludes this lesson. This is super important that you practice this, because practice will make perfect. There's several questions here related to what you've done. You're encouraged to go back and do those questions and try it again and again and again. Practice will make perfect. Thanks for watching.